All right, guys, welcome back to mathszoneafricanmotives, still on our O-level mathematics. And this is a revision that we're going to make under the logarithms. You know, logarithms is a very, very important topic in our syllabus, in our revisions, both paper 1 and paper 2. So it is something that you need to understand. You need to understand. So I've seen a lot of errors happening in our mathematics, especially under logarithms, and also the part of indices, which is the exponents. I'm going to have another tutorial with you guys under exponents, but this one is specifically for logarithms, but they do work hand in hand. Logarithms, the laws and everything is taken from our exponents or indices. So guys, we need to understand our logarithms. All right, so I'm not going to waste much of your time, guys. We're going to quickly rush through these persons. But before that, as I always do, just a little basic about these logarithms that we are talking about. Remember, I referred actually these laws when we're revising other questions on logarithms that you just need to understand the laws of what? Logarithms. So from our laws of logarithms, let us just refer this as A and B, the logarithm of A plus the logarithm of B. Take note, it gives us the logarithm of A times B. What is being multiplied here? It is not the logarithm to the logarithm, no. These are numbers that are presented. A and B represent numbers. The logarithm of 2 plus the logarithm of 3. Please, guys, understand this. This is not the same. It is not the same as the logarithm of 2 times the logarithm of 3. No, they are not. It's a different presentation at all. This here is the same as if we take our logarithms. I want you to understand me. I want you to understand me here. If we take this, the logarithm of 2 plus the logarithm of 3 from the law of the addition, that if you're adding, this indication indicates that you're in base of 10, the bases are the same. So it means if the bases are the same, let's say this is base of x and this is base of x, this is also going to be base of x. So if I'm not indicating the base, what does it mean? It means we are in base of what? In base of 10. So these numbers here that we are seeing, these logarithms that we are seeing here is the same as the logarithm of 2 times a 3 like this. Okay, no problem. This is maths, guys. You see, the advantage of maths is something that we can prove. All right, this is what I'm trying to say. The logarithm of 2, this is your log here, this one. The logarithm of 2 plus the logarithm of 3. Okay, the logarithm of 3 like this. It gives us what? 0.778 and so on. So let me just fix my calculator to 3 decimal places so that we just save our answers to 3 decimal places. This is 0.778. This is the addition of logarithms. 0.778. Okay, log 2 times log 3. No problem. Let us go to the calculator. Log 2 times, just going to put a times here. This is the indication, isn't it? This is what it indicates here. It indicates a times like this. This is 0.144. These two are not the same. What was the answer? 0.144. It's not the same, but these two are the same. Okay, let's present. We already added these two logarithms. We got what? 0.778 is equal to, let us do this, the logarithm of like this. This is it. Log of 2 times a 3 like this. Under 1 log like this. It gives us what? 0.778. The presentation of a log, please bear in mind. Why am I explaining this? This is going to affect us a lot. If you do not understand this, in your simplification, you are going to obtain correct answers from wrong calculations, of which The calculations are important. Paper 2, calculations. And also it affects you. Once you go to your A-level, you're now doing advanced mathematics. It affects you a lot. You do not know the basics of your logarithms. You do not know. So it affects even your A-level mathematics. So understand the laws. Understand them. All right? The same thing for a subtraction. This is same as if you're subtracting, you're going to divide the numbers, not the logarithms, no, the numbers. All right? The same thing for a multiplication. Let's say I've got p log of a, which is multiplying. This is going to be just raised to be an exponent of a. Some they use n, some they use p, anything. You can use n here, you can use n. It's one and the same thing. All right. I'm going to explain these laws as we are moving on. So these are your laws. Then you have to understand your basics from your conversion from a log to an index and so forth. So we shall see those typical questions as we are answering our questions here. So we're given the first part of our question here. It is given that the logarithm of x is what? A 6. And the logarithm of y is -2. This is from, this is actually taken from our Maths Today. Yeah, from Maths Today, book 3. This is Maths Today, book 3. You check Maths Today, book 3. Yes, from your logarithms, you'll see typical questions of this type. All right? So no problem. Let us just check. So this is given that the logarithm of x is what? 6. The logarithm of y is -2. Evaluate log xy. So those laws now, they're into application. They are into application now. What will be the logarithm of xy? All right, that is the first part. What is going to be the logarithm of xy? Take note, what is being multiplied? It is what? X and y, x and y. A and B, A and B. Where was this taken from? Addition of logarithms. Addition of logarithms. So this was taken not from log x times log y, no. From log x plus the log of y, like this. That is the law. That is we're having here, which gives us what? The product of what? Those terms under a single logarithm. So this is it. Once we have this as a single log, we can have its equivalent. What is the equivalent of log x here? The equivalent of log x is 6 plus the equivalent of log y. What is equal to the log of y? The log of y is equal to what? To -2. So therefore we combine 6 plus -2. Remember, plus and minus, it gives us a minus. So it's 6 minus 2, which is what? A 4. I'm not worried about the answer when you talk about maths. No, this answer is nothing. It's nothing. I'm worried about where it is taken from. How was it obtained? Be careful when you're answering your questions. Be very, very careful. Use the laws properly. All right, let us check this one. The logarithm of, which is b, in this case, this is our b. The logarithm of 1 over the square root of x, like this. Okay? Are we still having our logarithms in? Yes, we still have. Because there's a log there. But the condition here is not of a log, this one. These are your indices, the exponents. Tadzoka kuma exponents. Wakufangoshanisa ma laws ako ema exponents. That is the condition there. Ma exponents are kumboti chi, ma laws edu are kuti chi pana. How do we simplify this? 1 over the square root of x. Where was this taken from? Rakabva kupi. Okay, that's okay, my laws. That's okay. My laws edatoragoti. Anything that is raised to the exponent of -1, meaning to say the inverse, you know what, inverse of a number, which is 1 over x. Saka chiroti square root watiri kuona uyu akatoreizwa uyu watiri kuona uyu. Square root wedu ana 1 over. Akangofanana nekuti ndi square root of x to the power of -1. zvinova zvinozoconfuse manje kuti kana ndakuzonyora kuti square root of x to the power of -1, how do I simplify from there? Ewa pafanira kuita confusion apa. Square root of x akabva pari? X to the exponent of 1 over n means the nth root of x. Take note. X to the exponent of 1 over n means the nth root of what? Of x. What does it mean? The number that we are having here inside of the root sign is the number that is in the denominator. Meaning to say, for the square root of x, the number inside it's a 2. So that means it was x to the exponent of 1 over 2. If this was the cube root of x, that means it was x to the exponent of what? 1 over 3. Saka pandiri kunoona square root wa x uyu ndiri kuona chi x to the exponent of a half, x to the exponent of 1 over 2, but being raised to the exponent of what? A -1. Remember, exponent and exponent multiplies, so it will be x to the exponent of what? A -half. X to the exponent of a akanorezwa to the exponent of b. We multiply, combine this to be a single term, which is the same as x to the exponent of ba. So one and the same thing. Also, one and the same thing as x to the exponent of b to the exponent of a. One and the same. Hapana zvotambochinja, chin one. So ngatinzwisisei ma-laws. Pano pane mutemo panonetsa kuti kuite mistake. Ndava pane chi? Pane law. There is a law that is being applied. So the law is not supposed to bring confusion. No, hakuna mutemo unonza confusion. So that means in this case, we are going to have this one as x to the exponent of what? A -half in place of what? This 1 over the square root of x, which is this part here. So we are having the logarithm of x to the exponent of -1/2. That is what you're going to have. Zvichitibatsira chii? Zvigotibatsira chii zvatanyora? All right, toda tidzoke panapa. Tiri kumboti chii? Kana ndichinge ndine exponent like this part, if I am having a number, a term iri kumultiply a logarithm, ndichanoreza kuti inoita power of that logarithm. What if ndikaiwana iri power? What does it mean? Because all these substitutions that we are supposed to make for the logarithm of x or the logarithm of y, they must be made only kana wava nechinonzi a single logarithm, a single log. Only ndopatinoita substitution. Only that. Okay, let us go back here. Because hatisati taane single log. The moment yatiri kuona zvimapower zvese chirezwa rezvo, substitution cannot be made. So what is the condition? Kana iri power, it means tanga tichimultiply a log with that same power. And the power yatiri kuona panapa ndiyani? -1/2. So it means -1/2 anga achimultiply the log of x. This part ndo watiri kuda log of x kuti ave timuone paari as a single log. Ndoto tiringoda once tamuona akada as a single log, takutodzokera kusubstitution. Chakamirira log x ndiyani? Because log x tamunzwa kuti it is given that it's like if mbunzo mweche nokwanisa kunzi if this is equal. Kana ichi chakafanana nekuti. Saka taudzwa kuti log x akafanana na 6. Saka pandiri kunoona pana log x ari single log seizvizvi ndakunosubstitute chi number inonzi 6. So this will be -1/2 times a 6. That's it. -1/2 times a 6 in place of log x. So this is same as over 1. All right, got to calculate 22. That's 1 into 6. That's a 3. So you're going to have -3 over 1, which is what? Which is -3. So that is the idea there. That is the idea. You just have to play around with these questions. Try to revise as much as you can. We still have a long way to go. Let us just try to make a thorough revision, guys, as much as we can, so that we can catch up. All right, let us check this part again. It is the same application, but this one is an evaluation whereby already we are just simplifying. We are not given like log 16 or log this. We are just simplifying, applying my laws and my logarithms. So the first part there, it was to evaluate the logarithm of 16 divided to the logarithm of a 4. All right, ndokapana chimbotaura kuti ukatadza kunzwisisa zviri apa izvi uchanyora zvisiri izvo. Ndava chakadivide apa manhamba asi malogu. Asi log A divided to log B. Kwete, zvakasiyana. Zvakasiyana. Ndofunga ndataura nezvazvo. I proved this on a calculator. So this one zvikumboreva kuti chii zvirapa. Ndava azvipo panapa patataura nezve malaws edu. Atinombotaura nezve multiplication. Kuti ko log A akanomultiply log B zvichaita sei? Atavira ndataura nezvayo. Ko kana tikamdivide log A na log B, chii chichaitika? All right. This is what is going to happen. Whenever you're dividing your logarithms, like what we are given here, there are two ways to simplify this. In fact, there are so many ways. But there are so many ways. All right. The first way is that you could simply write this normally as a division, which is equal to the logarithm of 16 over the logarithm of a 4, not the logarithm of 16 over a 4 like this. This is wrong, huh? Zvatosiyana. Shandisa calculator yako kudivide zvirapa izvi. Woshandisa calculator yako kudivide zvirapa. Zvino zvakatosiyana zviviri izvi. Hazvina kufanana. So this part here zvikumborevei. The only way yandichakwanisa kusimplify panapa ndechekuti kana malogarithms edu aya akafanana, ndinokwanisa kutora this advantage kuti chero kuma numbers zviriko x na x vakafanana vanokanzelana apa. Zviriko kuma numbers izvi. Zviriko kwa algebra. 2 na 2 vakafanana tinokanzela toona chi? Toona 1. Saka chiro malogarithms acho akafanana, logarithm ya 3 na logarithm ya 3 vakafanana, chii chatinoita? Tinozvikanselawo izvi. Aiwa, zvakafanana kaizvi. Saka ndinoona chi? 1. Saka chandiri kuda panapa ndechekuti this part ishi tibudise this concept iya tiri kuona iyi ya log 3 over log 3 kana angava log 5 over log 5 handizivi. But how? All right. Tingafananidza sei manumbers edu 16 na 4. Zviviri zvinokwanisa kufanana muna 4 kana kuti muna 2. Zvimwe chete. Muna 4, 16 akafanana kuti ndiani? Ndi 4 to the power of 2. Ko iye 4 wacho ndiye 4 angambochinji because toda kuzvifananidza muna 4 macho imomo. Saka 4 hatingamuchinji. Unless detanga toda kuzvifananidza muna 2, 16 uyu angachafanana nekuti ndi log 2 to the power of 4. Ko 4 ndiani? Ndi log 2 to the power of 2. Ndiuri kuchuza zvauri kuda. Zviri kwauri. Still tinongona chi same answer. Chakakosha ndechekuti kana tapa this stage, we are supposed to go back now to this law. Tambotaura nezvayo. Kana ndikaona iri power, ndokwanisa kuidropa kuti iite sei imultiply a log. Ndikaona iri power, ndokwanisa kuidropa iite sei imultiply a log. Ndozvandinazvo inga 1 pana. These are powers, exponents. So what am I going to do with these exponents? I'm going to drop these exponents. Just drop an exponent A, don't drop an exponent power. So just randinani. Dika drop a 2, anonipa 2 log 4. Over, don't need the 1, on a 1 log what? 4. Log 4 na log 4 wakafanana. Just like x na x wakafanana, ngava kancelana. So this is going to give us a 1, but 2 over 1 dian, that's a 2. So this is going to give us a 2, which is the same application nezvatanga tichawana panapa. if we were to drop my exponent, this was going to be 4, the logarithm of 2 over to drop a exponent ya 2, tonaona 2, the logarithm of 2. So cancelana. 2 anopinda kangani muna 4, anopinda ka 2. All right. Latinini panapa. Tine nzira dzakawandisa. Okay. Ngatidzokei panapa. Atikamboti atina mutemo wemalogarithm wekudivide. Ndatatoshanda nazvo. It's only that we are not applying direct laws. We are applying indirectly my laws. Trukuma apply indirectly. Indirect. Okay, there's this one. If you can understand this, it's fine. But if you can't, you just understand this, it's fine also. Okay, let's talk about this one. If you are given this, understand this, please. The logarithm of A divided to the logarithm of B, not the logarithm of A over B. No, not this one. Is zvakabva panani? Pana log A minus log B. Ndokwa zvakabva izvo. Ko izvi rapa zvakabva kupi izvi? This one that we are seeing here, provided that these bases are the same, only provided that the bases are the same, it is equal to the logarithm of this number on top, which is A, in the base, mubesi B, ari denominator. This is a single log. Our language toiziva, takambotora nezvayo zvelanguage toiziva. That's okay panapa. The logarithm of 16 ushu. Tatisus akafanana nekuti ndi log 16 over what? Over log 4. Say izvizvi. Mutemo wedu uri kuti kana ndikaita log A over log B, mabase avo akafanana malogari. Zvakangofanana nekuti ndi logarithm wa 16 uyu wandiri kuona kumusoro uyu. Ari kuoneka mubase mani, mubase ma 4. Ndozvazviri kureva. Ndo mutemo mu logarithm ya A mubase mani ma B. Tikangonzwisisa izvi tapedza. Nekuda kwei ndava ichi chirapa ichi mubvunzo unokwanisa kuti wakatobvunzwa chitonzi simplify. Ngati mutsvake uripo mubvunzo wakadaro. Tinotowa nemubvunzo wakadaro unongoya uchingoti simplify chete. Kwete zvekuti kwa ichi kungonzi simplify zvafanasa pamuri kuona apa. Mubvunzo ringoti evaluate ushu. The logarithm of what? Of 1 over 4 in base 4. Mubvunzo unotarisirwa kuti utongomuziva kuti unoevaluatwa sei. Saka kana uchitoziva language yakadai zvinobva zvakubatsira ndava ndo language yatinongoda iyerapa. Ndopatira logarithm yani ya 16 mubase mani ma 4. Logarithm ya 1 over 4 mubase ma 4. Logarithm yani ya 25 mubase mani mubase ma 5. Logarithm yani ya 100 mubase mani ma 10. Tozvitakajaira izvo. Saka kana takajaira izvo, then we can simplify from there. Say ndinokwanisa ngozvibvunza this type of a person kuti right. Chinombonzi log chi ipower ndozviziva. Saka ndinoti 4 to the power ani kuti ndiwane 16. Ndeipi number yandinofanirwa kuraise panapa 4 wangu to the power ye number iyoyo kuti ndiwane chi? Ndiwane 16. Number ishi inombonzi chi? Ndi 4 to the power ani anotipa 16. Ndi 4 to the power 2. So 4 to the power 2 kana chitipa 16, it means the logarithm of 4 of 16 in base 4 is 2. Or tinotodzoka pane zviya zvokuti let log this be equal to that. Kana wada kuitako zvekuita macalculations ndiwe zviri kwauri. Let the logarithm of 16 in base of 4 be equal to x. Logarithm mubase ma x mubase ma 4 watiri kuona 16 watiri kuona akangofanana nekuti ndi 4 to the power of what? Of x. Kwava kudzosa kubva kulog kuendesa kuchi? Exponential function, indicial form, exponent form, index form. Do you know refer as the index or the indicial form? Mubase ma 4 16 anokwanisa here kunyorwa mubase ma 4. Zvechokwadi 4 to the power of 2016 akafanana na 4 to the power of x watagara tinayo. Mabase aya akangofanana chete aya. Mapowers akuna atofananawo. Saka na x ari 2 zvikureva kuti logarithm ya 16 ushu Base mafondian d2 davatati. Let this be equal to what? To x. So this answer is going to be a 2. Okay. So like I say, these logarithms is not a magic. With your calculator, you can prove that log 16 divided by log 4 is what? It's a 2. But the how part of you getting that 2, let it be in a proper way. Let it be in a proper way. Okay, no problem. Let us check another question. Let's hope shaona ma questions erudzi rwakadai angatibatsirawo paku revise. No problem. Then attend pane question. This one we are just subtracting. All right, subtraction ndo yedu yatakajaira. A law is there already. So I'm going to apply a law yedu and the logarithm of what? Of 5 minus the logarithm of 0.5. So mtemo wedu kana tango zviona izvi, provided kuti mabase aya akaita sei akafanana, tinoita sei tinodivide manumber mubase mumwe chete matiri, meaning to say base man base ma10. Kana base naonyirwa base ma10, saka tinosara tina log 5 over 0.5 sezvo tiri mubase mani ma10. Kusanyorwa kwebase, it's a common base runs base 10. So ndikadivide manumber aya ndowana chi. This was paper what? This was paper 1, no problem. So let us just divide because this was paper 1. So that means we are supposed to divide 5 over 0.5. How many decimal places do we have here? But 1 decimal place. So you multiply by 10 over 10 to remove the decimal place in the denominator. So that's 5 times 10, which is 50 over 0.5 times 10. To comma 1 to the right, which is a 5. And that is going to give us what? A 10. Saka zvino tikadivide manumbers aya ari 2 aya tinobudisa chi 10. So tichasara tina log 10 mubase man mubase make 10. Alright. Zvinhu zvekuti tinofanirwa kunge takuziva by now, takuita marevision kuti logarithm ya10 mubase ma10 ndiani? Ndi 1. Kubva pana logarithm ya1 mubase ma10, alright, anotipa iye 0. Logarithm ya10 base ma10 anotipa iye 1. Logarithm ya100 base ma10 anotipa iye 2. Zvinofanira kuzikanwa nemusoro. 10 to the power of 0 ndiani? Ndi 1. 10 to the power of 1 ndiani? Ndi 10. 10 to the power of 2 ndiani? Ndi 100. Kana kuti mazero atiri kuona mangani? Maviri, tina 2. Mazero atiri kuona mangani? I1. Tine here 0 panapa pana 1? Hapana 0, so that's a 0. We do not have a 0 there. So the way that you understand this must be important. And also this part does not mean log 1. Asiri log 1. Di 1 chete, pasina log. Pasina kana log. All right, let's hope we are together. So you try to revise as much questions as you can. That is very, very important in your revisions. Then the other part here we are given, it is given log 6. So tina log 6, which is this value, log 5, which is this value, then you are given to evaluate the logarithm of 30. So 30. The logarithm of what? Of 30. Okay. Tingamwana say log 30. Remember tataura nezve kuseparata kwema numbers. Number yatiri kuona inonzi 30 ish. Tinotova nayo from manumbers atakapiwa 6 na 5. Manumbers aya akatakurwa nemalog. Handizvo zvinoreva kuti ndi log 5 times log 6 ezvo. Zvinobva zvatosiyana. Ichokwadi kuti log 6 ndo atakapiwa na log 5 ndo vatakapiwa panapa. Icho chokwadi. Aiwa ichi ndo chokwadi chaicho, ndo zvatakapiwa panapa. But the separation part on its own, 30 here, is the one that we are separating, not the log. The one that we are separating first is the number that is referred as this one. What is it representing, this 30? That is the product of 5 and what? And 6. Apana chetachinja. Under the same log watanga tinayo. under the same log. But the question is, what made us to multiply these two numbers like this? Chi chakamboita kuti numbers aya azomultipliwa seizvizvi. Kadzoke kumalaws. Tangati chieda malogarithms. Malogarithms ani 5 nani na 6. Gati reverse kubva panapa chichatinoita. Kana uchibva panapa chichaunoita. You go to this stage, which is 5 times 6 under the same log. Then from there, your answer is what? Is log 30. So it's a reverse. Munyorero wangu wachingweti urikuita reverse chete. That's a reverse. But this time now, chiri kuzoitika ndechekuti unenge wakapiwa malogarithms acho a5 na6. So in the reverse part, you are now substituting as long you have this. Paunongoonera ichi chanyorwa as a single log chete. Alright, apa ndopada kuti ticorrect anapa. Because ndikuti pega pauri kungoona chete this one as a single log. Saka vazhinji vedu tiri kunyora seizvizvi. Patiri kunyora patiri kuona pamenge muchiansa maquestions enyu guys. Muri kunyora makati log 5 times log 6 izvizvi. Aiwa zviri wrong. Zviri wrong izvi. Hakuna mutemo unobva apa uchiti tinozoti log 5 plus log 6. Izvi zvakasiyana izvi. Ngatisambonyeperana izvi zviviri zvakasiyana izvi. Ndakuprovera kuti ukamultiply zviviri izvi, maanswer ako akasiyana nekuedha zviviri izvi. Ichi chatiri kuona apa chakafanira kuti ndi log 5 times 6 seizvizvi. Ichi hamenchorevechi. Hamenchotorevei. Hatina mutemo hakuna mutemo wakadhiraivwa kubva apa. Zvinotongosimplify zvoga kuti log 5 ndiani. Tikanomutora log 5 tikamudzigadzika panapa, to multiply na log 6 panapa hazviita, hakuna chatinowana. Then the other thing that we are asking is that, okay, say, why is it that here hatisi kusubstitute panapa kuti 5 times 6 posei tisiri ngonomutora log 5 wacho uchi na log 6 tovagadzika panapa? Aiwa zvakasiyana. Panapa chataita taseparata log 30 uchi and saka chatinacho panapa manamba akamultiply, manamba tiri kumultiply. Hatisati takuona log 5 ega kumuona kuti uyu ndiye log 5. Aiwa hatisati anaya. Log asati ane namba. Saka mutemo unotaura kuti log kuti achitakudzwa namba kana manamba ari maviri seizvizvi, kuti log achitakudzwa namba yake seizvizvi, kuti na log ab seizvizvi, kuti log uyu achitakudzwa namba imwe neimwe mukati umu. The only way yekuti atakudzwe manamba aya hunge achiedhewa manumbers iwayo nani nemalogarithms, log ya a plus log ya b. Ndo wava mutemo. It's a law now. Otherwise apa hatina log apa. Manamba angonyorwa akabatanidzwa pana log. Log hatisati tana log 5 na log 6. Patinongomunyora log 5 na log 6 kwatova kumutemo. Takutoshandisa mutemo. Otherwise, it was impossible to do that. But because of the law, we take it as an advantage. But this one now, it becomes wrong. This one, it becomes wrong. It's a wrong step that we can make. Even though our answer might be correct, but the step made there or the step taken there is what? Is wrong. So guys, let us correct Patrick Nyora Patrick answer my questions. To get at that correction. So log 30 panapa. Just only log 5 plus log 6 from this one. So log 5 down 0.6990 plus log 6. What is the value of log 6? 0.7781. Okay, this is paper 1. So we have to add my numbers. No problem. Let us just try to add them here. Let us just try to add them here. That is 0.6990 like this plus 0.7781 like this. All right, so we're going to add 1 plus 1. I mean 0 plus 1, which is a 1 here to add up another. That will be 17. Is that so? To number 1 panaba 10, 17 again. To number 1, 7, 14. To number 1 kuno, that will be 1. So paku add up guys to zongono confirm out is this correct and 1,4771. So this is how you simplify this. Then what about this log 1,200,000. All right, is that so? Tina log 6 na log 5 chete. But in order to simplify this 1,200,000, tingamu simplify say, in terms of my numbers, unokwanisa kuseparate because tine advantage yema zeros aya because tiri base ma 10. Saka tati kana tiri base ma 10, ma numbers akaita sana log 100 base ma 10, ma number ekushandisa as an advantage. So ndinokwanisa kuseparate using that concept, right? Apa titori mazero mangana 5, which means tina 100,000. Saka number yatiri kuona iri kunzi 1,200,000 inokwanisa kutoseparate as log 12, this one, this 12, this one. But achimultiply nani nemazero aya ari 1,000, mazero aya ari mangani ari 5, which means arimultiply nani na 100,000. Tikazvimultiply zvechokwadi izvi zvinototipa same log watanga tinayo. But chaitika manje ndechekuti ma numbers atiri kumultiply haasi malog. Saka tirifanira kuzoziva kuti right, ko tikazomanyora ari malog kubva apa anonyorwa sei? Ndio mubvunzo. Anyorwa sei? Tiri kuedda ma-logarithms. The logarithm of 12 plus the logarithm ya 100,000. Watinoziva kuti nemusoro ndiani? Ndi 5. Tine mazero mangani? Tine mazero 5. Ko log 12 tinaye? Log 12 hatina. Tingamuwana kupi kubva pane zvatinazvo? Ndava panapa hatina, tingori na log 5 na log 6. Ko 12 anobva kupi? Alright. So this one was just a type of a person who could stretch up, because in order for you to have this 12, this one, we need these numbers. You can simplify this aside. All right, log 12 aside. Log 12 is product of its prime factors. That will be 2 into 12, which is 6. All right, 2 into 6, which is 3, then 3, which is 1. So on those numbers, now 6 times 2, 3 times, which is this one is 6 times this 2. We have this 2 from where? From 5 and 10. Remember, 2 can be found from dividing the numbers 10 over 5, like this. 10 over 5 to energy 2. But as we do not want to have this, I mean, like to have the log 2, we want the exact value for log 2. What is the exact value? So the exact value there, we are going to subtract the logarithm of 10 minus the logarithm of what? Of 5. So that you know the equivalent now. Base ma 10, log 10 base 10 d1 minus log 5 base ma 10. Saka iya nombonzi log 5 uyu base ma 10 ndiani log 5 uyu base ma 10. Ndo ari ma numbers atina take note. Log 10 base 10 tinofanira kumuzana musoro atimbofita piwa this value avambokupa vakakupa log value ya log 10 base 10 kana kuti log 100 base 10. You must know it. So to log 5 now, all right, from these values that we are given. Log 5 there 0.6990. So that is the equivalent. So that's 1. Okay, just because of time, guys, let us just try to do this fast. 1 minus 0.6990. All right, so you're going to subtract this on your calculator. That is this, like I'm saying, guys, because of time, I'm just going to try to come back with part 2, part 3, up to when we finish it. 0.699, sorry, like this. That will be 0.301. So to 4 decimal place 0.3010, like that. Just maintain my digits. I'm going to say my decimal place or just maintain them. But this is log what? Take note. This is log what? This is log 2. But what are we looking for here? We're looking for log 12. So reason I to track a log 2 log 2 is because we are given what? We are given log 6. So we can obtain log 12 from there. This log 12 can be obtained. The logarithm of 12 is the same as the multiplication of two numbers, 2 and 6. Not the logarithm of 2, the logarithm of 6. This is different. You are not multiplying to the log of what? The log of 6, but you're adding, you're multiplying 2 times what? 2 times 6 under the same log, so that you'll be able to add log 2 plus log 6, whereby we have this value and log 2. Value ya log 2 ndiani? 0.301. Ndo value tukatoshandisa calculator yakunotombusanza iyoyi. Log 6. Log 6 takatombiwa kudala. Log 6 ndiani? Log 6 is given as what? 0.7781. 0.7781. Tono add my numbers. Like I said, guys, just calculator because of time. All right. Let me just fix my calculator back to 4 decimal places. Well, these are 4 decimal places, these ones. All right, so 4 decimal places, my answers are. So that's 0.3, 0.3010 plus 0.7781, like this. So tunobudisa 1.0791, 1.0791, like this. So this value is representing the logarithm of 12. So can actually represent the logarithm of 12. This part now can be substituted in place of log 12. Was chatanga chichaka pesa ndiye log 12 wacho. Takutomuziva kuti right, log 12 apa pana log time 2 times what? 2 times 12, 2 times 6, which is 12. So kana ndakuziva log ya 12 kuti value yake ndi 1, I just have to substitute 1.0791 plus for logarithm ya 100,000 ndoyatati kana tiri base ma 10 ma 0 cheta rungonotora as long this one it's a 1 ma 0 ando rungonotora cheta mangani 3 plus 2, which is 5. So that means our answer this is 5. Logarithm of 100 base of 10. So it simply is 10 to the power of what? That gives us what? 100,000. 10 to the power of 5. Then we can simply add. All right? This is a whole number, this one. So it's same as 5.00 So these zeros are actually going to add another this part. The same thing. 0791. So I'm going to add my numbers 5 now 1 to 1 6. Just like that. So guys, I want you to revise your questions. Revise to understand. Okay? So that mukano advance and maths makuita A level, muchenda kunana engineering, muchinoda. Guys, munofange muchitonzwisisa zvinezvi. Unosvika uchingonopiwa syllabus, wonzi shanda nesyllabus. Iwe wangoita medze kujuta juta kuti iyi ndoibatanidza ndoipa hadzichajuti medzi ikoko. Wautofanira kutoziva concept. Ndosaona kuti most of us we could do ma higher grades ku O level. A level ma grades anobva adropa. Nekuda kwei wakapasa nekuziva tactic wekungoti upase chete. That's why unaona kuti mane B ku maths kazhinji kacho. Not mamwe ma B aya. Ma B chao ma B maths chao. Ndo ma A ku A level. Ndo ma 5 points ku A level waya. As A yedu yekumaths yekumaths zone iyoyo EA yekumaths zvechokwadi. Ngaive saizvozvo. Let's revise to understand. So, like I said, we shall have more questions, guys, because of time. I know I left you guys somewhere, somehow. No problem. So, as an individual, try to revise my questions and my textbooks. Now, concept nayo. Was that concept maths imwe chete. Haifaniri kuva confusion kuvana kana as students. The concept must be the same. Concept maths haifika chinja imwe chete. Ma laws awo mamwe chete. Kana pane a law, that's why we not ma topic anima laws. Kana uti ma topic anima theorems. They are not well taught. Nekuda kwei. Nekuti pane theory, pane zvonofanira kufollowa. Zvasa a certain maths ekuti munhu anokwanisa ngoi kia so. Obva ngoti ndo answer. But pane law panonetsa kuti kana usingatopazivi kuti patsanangurire vanhu kana kuti iwewe upanzwisiwo as in panonetsa. You have to understand. So guys, let's do revise, and then we shall talk more as we are revising our question papers. We have got a lot of things that we need to talk about, just needs time. So for now, that's it. Gatungo share also my videos, Edu, and just try to share these videos to your friends. If you are new, subscribe, and also try to share my link, my certain groups, but tiri wayo to send my links Maths Zone African Motives so that we revise. We just need to work on more questions as time goes on.